So, our last video of the year, making simple DC motors. This first one is a mock-up of Michael Faraday's first motor. And the layout is pretty simple. He had a hanging copper wire that was free to pivot, and then he had some magnets at the base, and you can see this wire is free to pivot around the magnets. And then we need something to complete the circuit. So what he used was a cup of mercury. Mercury is a metal. Metals are conductive. So the mercury completed the circuit. I don't want to use mercury. I can't use mercury. This is a public building. So we're going to use salt water instead. So the setup is to take the neodymium magnets and place them in the cup. And then to keep them in place, simply use a piece of iron on the outside that then holds the magnets in place. Then if we place the cup there and position it so that the wire is hanging directly below. And then I just noticed that the copper is corroded from my practice yesterday, so I need to sand that free. Pause. So now the copper is hanging back up, and we're going to pour the salt water into this cup, but before we do that, we need a conductor that can reach down into the salt water in order to complete the circuit. So if you look over to the side here, I have a battery here that has 4 1.5 volt D cells hooked up in series. So it's 6 volts of electricity. And then turn this around so our cameraman can see. Hooked up the alligator clip. Okay, so we have one side of the battery hooked up to here, which is hooked up to this copper wire. The other side of the battery is hooked up to the aluminum foil, and then all we have to do is add the salt water to complete the circuit. And there we go. So we have a motor. Not a very powerful motor, but it is freely spinning counterclockwise of its own volition. So the electric current running through the wire is inducing a magnetic field, which is interacting with the magnetic field of that permanent magnet at the base. How cool is that? That's part A, Faraday's first simple motor. All right, part B. Part B is simple DC motor that works. This baby will crank. It will spin and it will produce oomph. Oomph is the formal unit of electromotive force. Okay, so given only 3/4 of a meter of enameled wire, a battery, 2 paper clips, and a magnet, we will make a motor that spins like crazy. The role of the paper clips, as you look in your diagram, is to make a stand for the motor. Then we'll hook up the battery to each side, and the only thing that will be able to complete the circuit is the coil. Okay, so the first thing we have to do is make the coil. So what you do is you wrap the wire around something round. You have to be careful when you use your finger. You can see my finger already turning red. Countless numbers of times students have done this, and then they wrap it too tight and they can't get it off their finger. So this is what is called an armature. Now, the goal of this is for these two leads to be perfectly centered in this plane as well as in this plane, which is easier said than done, and I'm not going to let you watch because it's tricky. Pause. So once you have the armature centered in those two planes, this plane and that plane, then you have to sand the wire. You sand it completely on one side and only on half of the other side. The reason for this is that you want the ability to have a continuous circuit, but you want it to be interrupted every so often. So you'll get an electromotive push on the armature, and then momentum will kick in because the current will stop, and then once the current engages again, then you'll get another push at just the right time, and that is what produces the turning. Okay, so the trickiest part is to get the placement of the permanent magnetic field. So we'll put this in place, and with any luck, there we go. We have a motor right off the bat. Pretty lucky. So hopefully you enjoyed this class. Hopefully it wasn't too bad doing things from home. I tried to make it as interesting and fun as possible. Have a great life.